The question is, will utilization increase every stage? Usually, let us say we took the shape and size of the block such that I'm talking this for a 28 nm process node, because I think most of you must have worked on 28 in your trial project, right? So I'm starting with 65% utilization, let us say. Now, depending on my netlist, my tool will do the optimization, right, at place stage. At floor plan stage, my utilization will remain same because I'm not touching my netlist. At place stage, my utilization will again remain same because I'm just putting all the cells in my design. I'm not doing anything. At place opt stage, definitely my utilization might increase or decrease. Usually it should increase, right? Why will my utilization increase at place opt stage? I need answers, guys. You are all trained VLSI engineers, I would call, not even freshers. You are all engineers. Suppose from 65 it has jumped to 68. What would be the reason for utilization increase from 65 to 68?
Here we are placing standard cells, no, sir.
Okay, I'm just whatever is outside, I'm placing them inside.
It means in place of stage, overlaps will happen, no, sir. Legalization of overlaps will happen. So standard cell will place for somewhat far from each other.
Okay,
The core area much.
overlaps per se will not affect utilization. That's a good point, Chiranjeevi. So what will overlap show is, overlaps will show that there is an error and in the log file, or if you do check place, it will show errors that there are overlaps. One more thing it will show is local density is more than 100%. That is all it will show. If there are overlaps, local density will be more than 100%. But it won't affect the overall block or chip utilization. I specifically mentioned place opt, and previously it is place. So at least from the difference in the name, can you come up with why the utilization might increase? Okay. What happens in place stage? Where what is HFNS? Somebody should explain HFNS.
High fan out net synthesis.
High fan out net synthesis. Very good. Can you tell me what is high fan out net synthesis?
I think the tool will identify the area where we have high fan outs. Then it will work on that.
Okay. Okay. High fan out net synthesis. Simple. In high fan out net synthesis, let's say my AND gate is connected to, right, 15 other gates. My high fan out net synthesis, what it will do is it will add buffers such a way that it will build a buffer tree in such a way that my load of the AND gate will reduce, right, and my buffers will drive So each buffer will now, I had 15 as fan out of AND gate. My AND gate output is connected to 15 cells. Now I have done high fan out net instance. What it will do is, for example, I have added 3 buffers here. My AND gate output will be connected to 3 buffers, preferably big size, which means 8x or 10x. And this buffer in turn will drive 5 cells each, so that my single gate is not overloaded by 15 fan out. It is now broken down into 3 pieces, right? This is high fan out net senses. What else happens in place? What are DRVs? I also mentioned in this sheet. What are DRVs? Fan out is anyways one of them. What else come under DRV? It is written here. You just need to see and
Yes, shorts,
no. Okay, shorts you can
tran-
give it. Only
transient,
tran, cap, and fan.
Max trans and max
Capacitance.
cap violations.
Yeah. So at play stage, transition fixes and capacitance fixes and max fan out. This is anyways we have seen. It will fix the fan out using HFNS. Max transition and max capacitance will also be taken care of. Is that right or no? Yes or no? Where does my transition and capacitance fixing happen? The first time my tran and capacitance fixing or DRV fixing, where does it happen? Does it happen in floor plan or where does it happen?
placement.
Placement, yes. To be precise, place opt after placement, right? So if there are, let's say my transition value, max transition value or max transition limit as they call is 150 PS. Max transition limit is 150 PS. Again, I will draw an AND gate. Now it is driving a NAND gate or an OR gate. Transition for this net is 180 PS. So is my transition for the net violating or not violating?
Violating, sir.
It is violating. Now, if the tool sees a violation during optimization stage, the tool sees a violation. What will the tool do for this kind of a net?
Adding buffers in the path.
Absolutely.
Buffers.
Right? The single most effective fix is cut the cap or cut the net and add buffers. Right? So at place stage, for this path, I was just having 2 cells, AND gate and OR gate. At place opt, I have 4 cells. Right? For the fan out thing, at place stage, I had 16 and plus 15 is 16. At place opt, now I have and plus 15 plus 3 buffers, right? Which makes it 19. So at place stage, it is 16. My place opt stage, it is 19. Here place stage, it is 2. At place opt stage, it is 4. So my number of cells, did it increase or decrease? Increase.
Increase.
So from my place stage to place opt stage, did my core area increase or decrease? Core boundary, height and width of the core. Between place stage and place opt stage, did the height and width of the core, did it increase or decrease?
Remain same.
Absolutely, it remains same. But the number of cells that have to sit inside the core has increased, right? So will my utilization increase or decrease?
Increases.
Absolutely, right? Similarly, this is at place. Now we go on to CTS. At place stage, remember we have zero skew. So there are no clock cells. The clock is directly going to your flops. At CTS stage, I will have clock buffers getting added, right? At CTS stage, I will have clock buffers getting added. So more cells will get added to my design. What will happen? What will happen to the utilization?
Increase.
Increase.
It will further increase, right? Now at post CTS, if I go to post CTS, till place, I do not have any hold, right? Till place, I do not have any hold because there is no skew. But at post CTS, I will have hold violations.